When wrapping up our series, we mentioned that a valuation analysis like this is not about getting to a perfect figure, but instead about a disciplined and logical approach to help us in evaluating our acquisition. We also pointed out how sensitive our analysis is to changes in our discount rate and long-term growth rate. And there are plenty of other assumptions we made. In fact, if we look at our 5-year free cash flow forecast, we have an entire section with all our assumptions that went into this here. Because our model should really not claim to be presenting the single correct answer to the valuation of Evergreen, you'll often see different sensitivity analysis included with the model. So let's look at how we might do that in Excel. So let's just clean up our formatting a bit to make this easier. We'll shrink this column to make it consistent with the others, and then wrap the text here to make it readable. That will just help the look of our sensitivity tables a little bit. Now speaking of, let's create a sensitivity analysis with the two most obvious inputs, our weighted average cost of capital and long-term growth rate. We saw in the previous episode just how a small change in either can have a noticeable impact on our enterprise value calculation. So a way we'll often see this presented is in a matrix where we show how changes in those inputs can affect our output of the Evergreen equity value. And Excel has a built-in tool to help us accomplish this. To begin, let's add a matrix here below our analysis where we have our long-term growth rate down the left and weighted average capital across the top. We'll look at 5 different values for each, so I'll just highlight 5 cells here. We'll merge these. And down the side here will be our long-term growth rate. Then we'll set our middle figure here to our default 2.5%. And then we want to increase and decrease this by a reasonable amount. So let's step our long-term growth rate by 1/10 of a percentage point in each direction. Then we'll do the same for our weighted average cost of capital. So we'll look at 5 different rates for this as well. The middle rate will be our default of 8.7%. And then we'll step these by 1/4 of a percentage in each direction. And then let's just add some borders here to make this readable. So first we'll put a border around the entire table. Then we'll add some for our headers. Let's do the same for what will be our outputs here. And then finally in the top left corner here, we'll put a border around this as well. And this is where we want to link to the output we're looking for, which in our case is our equity value. So we'll link to that result here. And then I'll just italicize that for formatting. And now we can use Excel's data table function to calculate the output value for all of these changing inputs at once. So we'll highlight the entire table, including the output in the upper left corner. Then this will be on the data header here under the what if analysis and the data table at the bottom there. Then our row input cell will be our weighted average cost of capital. Our column input cell will be the long-term growth rate. And if we click OK, and now we can just format this a little bit, you can see we very quickly calculated an equity value for Evergreen for 25 different scenarios. In the middle here is our default value, the same that we calculated in our base analysis, because the inputs for the weighted average cost of capital and long-term growth rate match our default inputs. So let's just format this a bit. We'll bold the row and column that correspond to our default values, and then just color this middle value green, just to make it clear that it equals the Evergreen equity value we calculated under our default assumptions. But in addition to that default value, we've also calculated equity values ranging from $9.6 million at a weighted average cost of capital of 9.2% and long-term growth rate of 2.3%, all the way up to an equity value of $11.8 million if we assume a cheaper cost of capital of 8.2% and a higher long-term growth rate of 2.7%. So you can see just how useful this can be. Our default value is $10.6 million, but we can also show the decision makers at our company how sensitive that figure is to the different inputs, and they can use that information accordingly based on how conservative or aggressive they want to be. And certainly these aren't the only inputs we can analyze. maybe we're a bit concerned about our year 1 revenue growth forecast. We're estimating a growth in the first year of 4.5%, but what would happen to the valuation if instead it were lower than that? Let's look at that in the same way and use our weighted average cost of capital as the second input variable. So the first thing we need to do here is add that revenue growth rate to our inputs up top here. The inputs for the data table analysis need to be on the same worksheet as the output matrix itself. So we'll just add year 1 revenue growth rate here. That was 4.5%, and then we'll link back to that in our 5-year cash flow forecast. Then let's copy our current table. We'll reset our equity value output to our equity value here. And then for the column, instead of the long-term growth rate, this is our year 1 revenue growth. And maybe in this case, that 4.5% is the maximum we want to see. So let's put 4.5% on the bottom here. And then we'll subtract 0.25% for the 4 different steps. Then we just need to clean up our formatting. We'll bold this bottom row here. Remove the green highlight from this middle one because that is no longer our default values. And add it to our default value down here. Now right now all the values in the table are just hard-coded because we copied and pasted that. But let's go ahead and do our data table analysis. So again, this will be on the data header, the what if analysis, and data table. Then our row input cell is again our weighted average cost of capital, and the column input cell will be our year 1 revenue growth rate. And as you can see in the middle column here, if we leave our weighted average cost of capital constant, we would reduce our equity value to $10.37 million if our first year revenue growth was 3.5% instead of 4.5%. Maybe not as large of a change as we would have expected, so it's nice to see that we could come in with lower revenue in that first year and still maintain our value fairly well. Granted, this assumes our gross profit percentage remains at 60%, which may or may not be reasonable. But we could also set up our sensitivity analysis to include this as the input across the top instead of the cost of capital. It all depends on how you want to set up your model and which inputs you want to see sensitivity analysis for. So it's very likely that if you build a model like this in the future, you'll want to include sensitivity analysis for your most important inputs, so that it's visually very fast and easy to see how changes in those inputs affect the outcome of the model. It helps us understand how our interpretations may change based on the assumptions we've used, and is very helpful to management as they make difficult decisions about deploying capital at our company.